Welcome to the screencast for Chapter 16, or Option E. And the last two sections are about soils and waste, what we can do with the waste that we generate. So starting with E7 on soil, plants and land organisms obviously depend on soil for their existence. That's how we grow food. And human activities tend to degrade or break down the soil. So soil degradation is human activity that reduces the capacity of the soil to support life. So this is basically when you farm the same thing over and over and you don't put any nutrients back into it, when you pollute the soil. Desertification is when you take, all the plants and everything out of it and basically leave it like a desert. Erosion, again, when you have wide open fields in the winter, as the winds come across, that tends to erode things away. So those are all contributing factors to soil degradation. Salinization, saline just means water, or means salt. So salt building up, nutrient depletion, and soil pollution, those are all forms of soil degradation. And there's not going to be a lot on the test about soil, but you should be able to recognize a few things. And hopefully it's enough that from your background, you kind of know what's going on because you live in a fairly farm-heavy area in Minnesota. So salinization isn't a problem we have in Minnesota, but it's a problem they have near the coast where they might have seawater coming in for the irrigation. But it's when soil is continuously irrigated, salts from the water get left behind. So even in an area like this, if you did a lot of irrigation, which we don't in Minnesota, but as you move across North Dakota or get down into Kansas and some of those other states, you will see huge irrigation apparatus, and that will tend to leave salt behind over time. There's just naturally some salt in there. And as the soil gets too salty, plants are going to die from dehydration or toxicity. And as you maybe know, salt actually makes you thirstier because of the imbalance it sets up in your cells. Nutrient depletion is normally not an issue if you let plants die and decompose where they grew. Then the nutrients are returned to the soil. Everything that was taken out of the soil is put back. But when we harvest crops, obviously we harvest it for the food. So then those nutrients have to be replaced. And you do that either by rotating crops so that hopefully when you rotate, like commonly in Minnesota, we rotate soybeans with corn. What corn takes out, soybeans put back. What soybeans take out, corn puts back. We also can use manure and artificial fertilizers. But excess fertilizer has environmental consequences too, which we talked about back with the water, where you have the soil runoff, and now you have issues with your lakes. Soil pollution is the result of things like mining is a big one. Excessive use of agricultural chemicals and improper disposal of toxic waste, those will all tend to pollute our soil. And when we pollute the soil, we contaminate the plants, and then everything that eats those plants ends up with the contaminants, so it just keeps moving up the food chain. It also, you run the risk of it ending up in our water supply and drinking it directly. SOM, soil organic matter, it represents the organic constituents in the soil after it composes. So SOM is a good thing. You want a lot of organic material in there. It's often referred to as humus. You might think of it as compost. But it's important because this organic matter tends to loosen up the soil and create more space for air and water. Earthworms do the same thing naturally, go through and loosen it up. So humus will naturally buffer the pH of soil, and unfortunately farming practices tend to affect the SOM levels in a negative way. So it's important to limit the tilling, to add manure, other organic material, and do things to limit the erosion. And things they can do to limit the erosion is keep a tree line, not plow or till up things until the spring, leaving the corn stalks out there in the winter to help hold the soil down. So humus holds on to the nonpolar organic pollutants, which is a negative because we don't particularly want those in there. But again, because they're nonpolar, they're not going to wash out with the water. So you can have pollutants build up in the humus or the SOM. Moving on to waste then, the increase in human population and just the overall increase in consumption by people has led to huge increases in solid waste. It's also increased the air and water pollution that we've talked about earlier. But regulations have had to increase to help dispose of all these things. So the simplest solution to solid waste is just what's open dumping. You pick a spot and everybody dumps it there. It's cheap, it's convenient, but there's a lot of health and pollution issues. If you can imagine, the garbage truck coming by your house and then just driving a couple miles away and having a big dump where it all goes, it's pretty nasty. But that was common practice for a long time. More often used are landfills, and it's a better option than the open dumping. What happens is an old quarry or some kind of natural pit, a big hole is filled up with waste and then it's covered over. The problem is we're running out of sites. We have filled up a lot of landfills. We're kind of running out of places to dig up and throw the garbage in. The other problem is that the waste needs to be kept from getting into the groundwater, so you need some kind of big liner in there to keep stuff from seeping down into the ground and into the water. And it also means that decomposing is slow because you're covering this whole thing up. It's like, putting things in a plastic bag and hiding it from the water and the bacteria and the other things that would help with decomposition. Another method is incineration. That's just a fancy word for burning. It reduces the bulk quickly, but it has environmental consequences, especially when things like batteries end up in the incinerator, then mercury and other toxic gases end up in the air. It also releases greenhouse gases, and then dioxins and a number of other toxins can end up in the air, especially, not only batteries, but different plastics, all the different synthetics we've created. When those get burned, there's the ability to release a lot of toxins into the air. So there's a number of things that really shouldn't be incinerated. And at the very least, even things that are pretty safe to incinerate, like paper, you're still going to end up with more greenhouse gases. So the ideal use for waste would be to reuse things. And reuse is just when, you take your water bottle and you reuse it multiple times. When you have a box, something was sent to you in the box and you reuse the box for another purpose. So no waste is produced, no energy is put into it. Recycling is the next best option, and recycling means that you have to do some cleanup, but it still reduces the use of raw materials, costs less energy, takes less energy, decreases the level of pollutants, and it decreases the need for a place for it in the landfill or any kind of waste disposal. The main challenges of recycling is that a lot of places you have to separate, and people are lazy. They don't like to separate. They want it picked up by the curb, don't want to have to go to any extra work. A lot of times it has to be clean. So there's some purification with different recycling materials. And most recycled materials, some recycled materials produce lower grade quality. This is especially true for paper. If you've ever used a notebook made out of recycled paper, you notice it's much more coarse and not as nice and smooth and shiny or as white as non-recycled paper. The cost of recycling has to be less than using the new materials, or companies aren't going to do it. If they can just go dig up new whatever metal they're looking for, or grow more trees and produce paper cheaper than recycling the paper, then there's no incentive for them to do it regardless of the effect on the environment. Metals have a huge savings by recycling. So getting people to recycle metals, getting companies to be on board recycling metals, that one's easy because there's huge savings. Because typically to get a metal, you have to mine the ore or the rock it's in. You have to pulverize that ore, and you have to somehow separate the metal out. And the separation technique often involves a lot of toxins, so all kinds of issues with it. So the other thing with metals that makes it pretty easy to recycle is many recycled metals are used as an alloy, so they don't worry about having it separated and purified. Aluminum would be the exception, but again, aluminum is easy to separate from other metals because of its low density. Also, many other metals have at least some iron in them, so you can use magnets to separate them. So metals is probably the most recycled item we have. Glass, not quite so much incentive here, not quite the money saving. And different colors have different compositions, so you have to separate glass by color. You maybe have seen where they have clear brown and green glass separated out. Good news about glass is it's easy to crush and melt, and it retains its quality over and over. Metals also retain their quality over and over. having the pure metal come back is a little trickier, but again, we use so many alloys, it's really not an issue. Plastics, also an easy thing to recycle. Recycled plastic, though, does have slightly lesser quality. There's lots of kinds of plastic. You might have noticed the symbol as to whether it's, a 4, a 5, a 6, or 7. So some plastics, some areas recycle, others don't. So recycled plastic is a little trickier, and it does tend to have to be separated either when you put out your recycling or when it gets to the recycling center. But it saves in crude oil, and we're not going to have an infinite amount of fossil fuels. Plus, plastics don't ever break down in landfills, so plastics are an important one for us to be recycling. Paper is also commonly recycled. I would say most people are pretty good about paper. It's a huge percentage of our waste. It can decompose, but it won't decompose easily in landfills just because of the way landfills are set up. Paper often also contains ink. Might have bleach in it from the white paper. It might be adhesives like on Post-it notes. So there must be some stuff that's cleaned out of it. And again, the recycled paper is less quality, but it's very good for newspapers and cardboard boxes, things that we use a lot of. So there's certainly a use for recycled paper. And the last type of waste to talk about is nuclear waste, which most of us don't think much about because we don't really know if our electricity is being produced by coal or nuclear power or water or wind. We just turn on the switch and don't think about it. But a huge amount of electricity is produced by nuclear power in this country, which leads to nuclear waste, which is radioactive. And there are two types of radioactive waste. There's low-level waste. That's generated mostly by hospitals and research labs. You think about hospitals with their different imaging techniques as well as the radiation that they provide as part of a therapy. That all generates this low-level waste. It has low activity and it has a short half-life, so it can usually just be stored in a cooling pond until it's safe and then disposed of with one of the techniques above, like in a landfill. High-level waste is the one that we have a real issue with. This is from nuclear power plants, from the fuel rods specifically. It has high activity and a long half-life, like of thousands of years. It's much lower volume than the low-level waste, so that's a good thing. It also is cooled initially in deep, cold pools, but then at some point, when its activity has gotten down enough, it's encased in glass or ceramic to keep it contained, and then it's packed in metal and concrete containers. So you're getting the idea of just how nasty this stuff is, that you encase it in glass or ceramic, pack it in metal, and then pack it in these, concrete containers several feet thick. And then the idea is to bury it in a remote, geologically stable place. The problem is nobody is really anxious to say, hey, come put it in our backyard, or come put it in this national park, or come put it in this, area. Plus, you have to get it to that area, which means you have to transport it. So a lot of high-level waste is actually sitting at the site of the power plant where it was produced, and we're still trying to figure out where it's going to be buried, still trying to get areas to agree to accept that waste, and to get cities to agree to have it transported through, whether it's on train or by semi. So that kind of summarizes the issues going on with soil and waste in general.